In this video, I will be explaining how to solve and graph absolute value inequalities. Let's get started. This is what the absolute value symbol looks like. It's just two straight lines, and in this example, I just have an x inside, but you can have anything inside. You can have numbers, you can have variables, you can have expressions like 3x plus 2 or whatever. As long as they're inside those two lines, then that would be the absolute value of whatever is inside. When we talk about absolute value, we're talking about the distance that something is from 0 on a number line. So because we're talking about a distance, it's always positive. You wouldn't say, I traveled -3 miles, right? When you're talking about a distance, it's never negative, it's always positive. So whatever is inside the absolute value symbol, the two lines, it comes out positive. Now let's look at a few examples. Here are some examples of absolute value. So I'll just go through these pretty quickly just to show what absolute value does or what it means. So the first one, the absolute value of -5 would just be 5. It just comes out positive. The absolute value of +5, going to the right side now, would be 5. This is where a lot of students get confused. A lot of students think that it comes out opposite. So a lot of students might say this comes out to be -5, but that's not right. It just comes out as +5. So it doesn't come out opposite, it always comes out positive. So -12, the absolute value of -12 would come out to be 12. The absolute value of 12 would be 12. And right here where we have the absolute value of x equals 4. So this is kind of a different example, but what that means is x could equal 4, but also x could equal -4. Because whatever is inside the absolute value, it always comes out positive. If I plugged in a +4 for x, then that would come out to equal 4. Or if I plugged in a -4 for x, that would also come out to equal 4. So we get two answers there. And then same idea with this one, the absolute value of x equals 2. That means x could equal a +2, or x could equal a -2. Because again, either way, if I plugged in a 2 or a -2 for x, those would both come out to equal 2. Here are some general steps to keep in mind when we are solving absolute value inequalities. So the first step, get the absolute value by itself. So whatever is in the two lines, get that by itself first. Step 2, make a sandwich, and I will explain what that means in a second, and I'll show you some examples. And then step 3, solve for the variable, and the variable will be in the middle of the sandwich. Here is what I mean when I say make a sandwich. So say you have an equation like this, and this one's not an inequality because I just have an equal sign, so it's just an example of an absolute value equation. So the absolute value of x plus 2 equals 3. So that means, like in our previous example, x plus 2 could equal +3, or it could also equal -3. Because if I have the absolute value of 3, that comes out to equal 3. If I have the absolute value of -3, that also comes out to equal 3. So the absolute value of x plus 2, it could equal 3, and it can also equal -3. So this is what that looks like when I say make a sandwich. See, there's the -3 and the 3 on the outsides, and then I have two equal signs here and here. And then the equation came from what was inside the absolute value. So I had the absolute value of x plus 2, so the x plus 2 is here. Because whatever is inside the absolute value, it can equal the positive or the negative version of what it's set equal to. So where this one is equal to 3, that means that x plus 2 could equal positive 3 or negative 3, and both of those would work in this equation. This equation came from the previous example where I said x plus 2 could equal 3 or negative 3 because it was inside the absolute value. So this is just a quick reminder of how to solve a regular equation. So when we're solving for x, we would subtract 2 on both sides so that we get x by itself. If I finished solving that, that would be x equals 1. That's just a regular equation without the sandwich. Now I'll show you an example of what it looks like with the sandwich. So here I have that same equation, but now I have sandwiched it. So now I have two equal signs. So I drew lines through both equal signs. And then when I do minus 2, I make sure that I do minus 2 in all 3 sections. So in a normal equation, we just have the 2 sides of the equal sign. Now we have 3 different sections. So we just have to make sure we do the same thing in all 3 sections to keep that equation balanced. Here are a few examples of absolute value inequalities that we can solve. So if you remember when I showed you the steps, step 1 was to get the absolute value by itself. So if we look at number 1 here, we have 2 times the absolute value of 1 plus d is less than 4. So the very first thing is to get the absolute value by itself. So I need to get rid of that 2 out front so that I just have the absolute value by itself. So I would divide by 2 on both sides. So then I'm going to write up here so I have more space. The absolute value of 1 plus d is less than 4 divided by 2 is 2. Okay, now the absolute value is by itself. There's no other numbers outside that absolute value on that side of the equation, or that side of the inequality. So the second step was to make a sandwich. So that means I'm going to copy this sign over here, so it's a less than sign, and then I have positive 2 over here, so I'm going to put a negative 2 on this side. Because, again, when it's absolute value, it doesn't matter if the inside is positive or negative, it's going to come out to equal the same thing. So now I have a sandwich, and I'm going to draw my lines through my signs so that I have 3 sections. And now I'm going to just ignore the absolute value sign for a little bit, and I'm just going to imagine this is just 1 plus d. And forget about the absolute value signs for a second. And now I'm just going to solve for d. So since I have 1 plus d, I'm going to subtract 1, and I'm just going to make sure I subtract 1 in all 3 sections. So then I get negative 2 minus 1 would be negative 3 is less than, and then those ones cancel. So I have d in the middle is less than, positive 2 minus 1 is 1. So then this would be my answer. So negative 3 is less than d is less than 1. Let's look at number 2. So the first step is to get the absolute value by itself. So right now I have this 2 dividing on the bottom, and that is not inside the absolute value, so I need to get rid of that 2. So I'm going to multiply by 2 on both sides. So those cancel each other out, which they actually just divide to 1. That's what's happening mathematically, but 1 times anything is that thing, so it doesn't matter. So then I'm going to come up here again. The absolute value of 3 plus a is greater than 13 times 2 is 26. So now I've got the absolute value by itself. I don't have any other numbers outside of the absolute value on that side of the equation. So now I'm going to make a sandwich. So whatever sign this is a greater than sign. I'm going to copy that same sign over on the left side. And then this is a positive 26, so over here I'm going to have a negative 26. And then I'm going to draw my lines through the signs to make the 3 sections, and I'm solving for a. So again, ignoring the absolute value signs for a second. So just imagine this is just 3 plus a, and I'm trying to solve for a, so I'm trying to a by itself. So I would subtract 3, and make sure you do the same thing in all 3 sections. So negative 26 minus 3 is negative 29. I'm going to bring down my greater than sign. In the middle now we just have a. Bring down the other greater than sign. And then 26 minus 3 is 23. And that's my answer for the second problem. Now looking at number 3, again I have to get the absolute value by itself first. So that one is dividing by 2. So I need to cancel out that 2 first. So I'm going to multiply by 2 on both sides. So I get the absolute value of x plus 3 is less than or equal to 6 times 2 is 12. Now the absolute value is by itself on that side of the equation. So now I make a sandwich. So I'm going to copy that same sign, less than or equal to, over on the left side. And on the right I have a positive 12, so over on the left I'll put a negative 12. So there is my sandwich, and now I'm going to draw my lines through the inequality signs, and I'm solving for x. So we have x plus 3 in the middle, so I'm going to minus 3. Do the same thing in all 3 sections. So negative 12 minus 3 is negative 15. I'll bring down that sign, less than or equal to, and then we have x in the middle. Bring down the sign, and 12 minus 3 is 9. So there is my answer there. So I've been writing these all together, but you could write them separate. Like you could say x is greater than or equal to negative 15, and x is less than or equal to 9. So those two things are saying the same thing. So you can write them separately or write them all together. Okay, last one, number 4. So this one, I still have to get this absolute value by itself. So first I'm going to multiply both sides by 6. So then I get 2 times the absolute value of c minus 4 is greater than or equal to 4 times 6 is 24. My absolute value is still not by itself because I have this 2 on the outside, so I have to get rid of that 2. So I'm going to divide by 2 on both sides. So then I get the absolute value of c minus 4 is greater than or equal to 24 divided by 2 is 12. Now the absolute value is by itself, so now I can make my sandwich. So I'll copy that sign over on the left side. And then over here I have a positive 12, so on the left I'm going to put a negative 12. Draw my lines through my signs, and then I'm solving for c. So I have c minus 4, so I'm going to add 4 in all 3 sections. So negative 12 plus 4 would be negative 8. I'm going to bring down the greater than or equal to sign. In the middle I just have c. Bring down the sign, and 12 plus 4 is 16. So there's my answer. And again, I could write that like c is less than or equal to negative 8, and c is greater than or equal to 16. So you're reading that from the middle out. That's why that sign is flipped, because I'm reading it from the c out. So c is less than or equal to negative 8. And then c is greater than or equal to 16. And there's my answer. Now let's talk about what makes inequalities different from regular equations with equal signs. So if you watched my inequalities video, you know this already, but whenever you multiply or divide by a negative, you have to flip the inequality sign. So this is just a way for you to remember. Just imagine someone shaking their fist like this old man, shaking his fist and saying, "Those flippin' negatives." So just remember, whenever you divide or multiply by a negative, you have to flip the inequality sign. So let's look at a couple examples where we would need to flip the sign. Let's look at this first example. So we have our inequality, and the absolute value is already by itself, so we don't have to worry about getting it by itself first. That's already done for us. So then we can just go right into making a sandwich. So I'm going to copy that less than sign over on the left side. And then on the right, we have a positive 17. So over here, I'm going to put a negative 17. And then draw my lines. Now I'm solving for v. So we're just going to ignore those absolute value symbols. And we're just going to imagine this is just like 5 minus 2v. So we're solving for v. So I would subtract 5 and do the same thing in all 3 sections. So negative 17 minus 5 would be negative 22. I'll bring down the sign, and then those 5s will cancel. So we'll just have a negative 2v is less than 17 minus 5 would be 12. So we're still solving for v. We still have to get v by itself. So then I would divide by negative 2. Do the same thing in all 3 sections. So negative 22 divided by 2 would be a positive 11. I'm going to hold off on the signs for a second. Well, let's just figure out the numbers first. So those negative 2's cancel, so I have a v in the middle. And then 12 divided by negative 2 is negative 6. So now, because I divided by a negative number, that's when I flip the sign. So these signs started out as less than signs, but then I divided by a negative, so now I flip it to greater than signs. So it's just like that. Just whenever you multiply or divide by a negative, you flip the sign. Okay, let's look at number 2. First step, I have to get the absolute value by itself. So I have this negative 2 on the outside that I have to get rid of. So I'm going to multiply by negative 2 on both sides. So then I get the absolute value of b. And then, again, because I multiplied by a negative, then I would flip that sign, is less than negative 20. And it's kind of already solved, this one, because we just had the b by itself in the absolute value. So I'm just going to put that same sign over here and put a positive 20. So we can write it like that, or we can say b is greater than 20 and b is less than negative 20. So just remember, whenever you multiply or divide by a negative, you flip the inequality sign. Now we're going to talk about graphing absolute value inequalities. So when I say graphing, I mean we're graphing it on a number line like this. So if you have 2 less than signs, so we have a less than or equal to, then we say and. So there's the example. We have x is, well, if we're reading it inside out, we would say x is greater than negative 3 and x is less than 3. So that's what it looks like on the number line. It's like x is in between negative 3 and 3. So this line here, that represents all of the numbers that x could possibly equal. So it doesn't actually equal negative 3 and 3. It gets really, really close. It could get to negative 2.99999 or positive 2.99999, but it won't actually get to 3. But it can equal every number in between. On the second example, when you have 2 greater than signs, so you have greater thans or greater than or equal to signs, we say or. So x is less than or equal to negative 3. That's this one down here. Or x is greater than or equal to 3. So those ones go in opposite directions. So x is less than or equal to negative 3, or x is greater than or equal to 3. Okay, I have 2 more practice problems. We're going to practice all the way from the beginning. So we're going to solve the inequality first, and then we're going to graph it on the number line. So number 1, first thing we have to do is get the absolute value by itself. So we have this minus 3 that is outside of the absolute value, so we have to get rid of that first. So I'm going to add 3 to both sides. So then we get the absolute value of 5x is greater than 12 plus 3 is 15. Now the absolute value is by itself, so now we make a sandwich. Copy the same sign over, and then we have positive 15, so over here we'll have a negative 15. Draw our lines, and then we are solving for x. So we would divide by 5 in all 3 sections. So then we get negative 3 is greater than x greater than 3. So if we graph that on the number line, first I'm going to put my points, and these are going to be open circles because there's no equal to underneath, it's just less than. It's not less than or equal to. So they're both going to be open circles. So I have one at negative 3 and one at positive 3. And then they're both greater than signs. So that means we're going to be going in opposite directions. Because if we separated this out again, reading from the inside out, we would have x is less than negative 3 or x is greater than 3. So less than would go down to the lower numbers, less than negative 3, or x is greater, that's going to go up to the higher numbers, greater than 3. So that's how you would solve and graph the first one. Now looking at number 2, so our first step in solving is to get the absolute value by itself. So we have this negative 2 on the outside that we have to get rid of. So I'm going to multiply by negative 2 on both sides. So then we get the absolute value of 3a. And then this is tricky because I multiplied by a negative. That's when I flip the sign. So instead of a less than or equal to, I'm going to do a greater than or equal to. And then 9 times negative 2 is negative 18. So now the absolute value is by itself. So now I make a sandwich. So I'm going to copy this sign over. And I have a negative 18, so I also need a positive 18. And then I'm going to draw my lines through the signs. And we are solving for a. So I'm going to divide by 3 in all 3 sections. So 18 divided by 3 is 6. And then we have a in the middle. And negative 18 divided by 3 is negative 6. So again, if we wrote this separately, we would have a is less than or equal to 6, and a is greater than or equal to negative 6. So I'm going to start by putting my points on the number line, and these ones are equal to, so these will be closed circles. So I have one at negative 6, and one at positive 6, closed circles. And then a is less than positive 6 and greater than negative 6. So this is where we're going to have the line in the middle. Okay, and there is just a brief overview of how to solve absolute value inequalities and how to graph them on the number line. Thank you so much for watching. I hope this was helpful. Please like and subscribe, and if you have any other math topics that you would like me to cover in a future video, please comment below. Thanks for watching.